moves along the x-axis so that its velocity at any time t is given by v of t. So we have the velocity equation right here. Okay, so there's the velocity equation. It says at time t equals 0, the initial position of the particle is 7. So we know s of 0. We know s of 0 is 7. This is a start value. Okay, that's where your position function's starting from. So like you're at mile marker 7, you're starting from there. All right, find the acceleration of the particle at t equals 5.1. This is only worth 1 point. Okay, anytime they give you an equation on the free response, the very first thing you should do is type it into y equals. So go ahead and type this into y equals. After we get problem number 1, we can, if we really do want to do food, we can think of a food solution. Okay, it is pretty expensive. All right, so plug this into y1, So you're going to put add alpha exit and type in x to the 6th power minus 13x to the 4th plus 12 over 10 x cubed plus 3. So somebody tell me that equation since I can't see it.
I cannot have
All right, I would definitely, let's try and, this will go fast if we stay focused. Okay, it's x to the what? X to the 6th. X to the 6th what? Minus 13x to the 4th. Okay, keep going. Plus 12 over
10x to the 3rd.
10x to the 3rd. Listen up, guys.
Plus 3.
Okay, 10. Dang it. 10x to the 3rd. I hate typing on the calculator like this. All right, there's the graph. I'm going to zoom 6 it. I don't know if I'm going to need that right now, but I have it in there. It says find the acceleration of the particle at t equals 5.1. So all you need to let them know on the AP exam is that you know to find acceleration, you need to do what? Take the derivative. So you're going to go v prime of 5.1. And then all you got to do is put the answer. And you're going to round to 3 decimal places. So I'm going to go to my calculator. I've already got it typed into the y equals. So I'm going to go to my home screen. I'm going to math what? 8. Math 8. It's derivative. Math 9 is integral. Okay. I'm going to go vars, y vars function y1 of 5.1. Hit enter. 6.492. Okay. And it doesn't really, they don't care what you round to. Okay, 6.491 or 6.492. It is irrelevant. You get 1 point. You only get 1 for that. Okay, next one. It says find all values of t in the interval from 0 to 2 for which the speed of the particle is 1. Speed is what? Somebody remind me what speed is. Absolute value velocity. Very good. Speed is, guys, listen. Shh. Speed is the absolute value velocity. They want to know, find all values of t in the interval from 0 to 2 for which the speed of the particle is equal to 1. So I want to know when the absolute value of v of t is equal to 1. If you put that down, that is worth 1 point. By itself, right there. Nothing else. You knew to take the absolute value velocity because that's the definition of speed is the absolute value velocity. Okay, and you set that equal to 1. Now I'm going to let my calculator do that work. So I want to know when it's going to equal 1. So all you have to do is go back to your calculator, go to y equals. I'm going to do the absolute value velocity. So how do you do absolute values on your calculator? Math, num, 1. And I'm going to do vars, y vars, function y1. I've got absolute value 1 of y1. I want to know when the absolute value of velocity is equal to what? I'm going to put 1 into y3. And then I'm actually going to turn one of these graphs off. What graph do you want me to turn off? The top, y1. Just highlight the equal sign and hit enter. That'll turn that graph off. And then I'll just be looking at the absolute value velocity, which is speed. And I only want to look at it from what to what? Go back to the question. From 0 to what? 0 to 2. So I'm going to do my window. I'm going to set my x min at 0. And my x max at 2, hit graph, and I just need to see where it equals 1. Okay, it looks like it crosses 1 in 2 places. Do you see it? So all you have to do is go second trace what? So you go second trace. Nope, you go second trace, not 0. Intersect 5. And this, mine, don't look at mine. Yours asks different questions. It goes first curve, second curve, guess. The iPad doesn't do it the same way. So when it says first curve, use the left and right arrow key and move your cursor to the first one where the red graph crosses the green graph, or whatever colors it is. Is it red and green? I don't know what it is on your calculator. What's what? Is it black and red? Okay, so see where black crosses red? So go to the first one, move your left and right arrow buttons over to where it crosses, and you're going to actually, I'm going to do the one over here. Mine does it different, though. It says mine does left bound, right bound, guess. You're going to do a first curve, and then a second curve, and then a guess, and you will get 0.771. 0.771. Then you got to do the other one. So please do it. It's not the same on the iPad. You need to do it. So the answer is going to be T is 0.771 or whatever.
Would you have to round up to 0.772?
It doesn't matter. They don't care on rounding. I've gotten the answer key 0.772 or 0.771. They do not care about rounding at all. As long as you just go to at least 3 decimal places. If you're not comfortable going to 3, write them all down if you want. Okay? And then what's the other one?
1.401.
Yep, 1.400. I guess 401 if I want to do it, if I round up. So there's your answers. The speed of the particle is 1 at 0.772 and 1.401. So you get 1 point for this and 1 point for the answer. That was it. Pretty straightforward. Letter C, find the position of the particle at t equals 4. All right, how do you find... All right, I want to explain this really well here, and I'm going to hammer this kind of before I leave tomorrow. How do you find the position of a function or position of the particle? How do you find the original function value? I've been telling you, there's a little formula you use. You got to know where it starts, and then you just add in how much it increases or decreases. How do you add in how much it increases or decreases? Integral of, in this case, velocity, but it'd be the integral of the first derivative, which is what? What is the integral? Displacement. It's always start plus displacement. So if you want to find the value at 4, all you have to do, and by the way, this is 4 points on this problem. 4 points. And I'm going to tell you how you get all 4 points. Okay, S of 4 or X of 4, they don't care if you use S or X. Okay, X of 4, if you put 7, why 7 here? Go back to the original problem, read it. It's easier if you're looking at the problems. It's our start position. Remember we wrote up here. They told us the initial position of the particle at t equals 0 is 7. So that's where we're starting from. So 7 plus, by the way, that's 1 point. Just going 7 plus. The integral, now this is important. Where did that start value, at what point in time did it occur at? Because you got to measure the displacement from there.
0?
At 0 seconds. Now, that's not always going to be the case. They might tell you the start value is at 1 second it was 7. And if at 1 second it was 7, you would start your integral at 1. Okay?
So
So
what's it in S?
what's position?
Okay.
S of t. You can do x of t or s of t. It doesn't matter. Generic is s. They did say it's a position x, I believe. Let's see. Particle moves along the x-axis. So a lot of times with x-axis they do x of t, but the generic is s of t, and they'll accept either. Okay, so then all I got to do is start plus displacement. I want to go to the displacement from 4 seconds of velocity. You don't even have to write the equation. You can just put the label. All right, let me tell you how much right now you got with that. You got 1 point for this. You get 1 point for this. And you're going to get a 3rd point for the answer. Okay, so S of 4. So I'm going to take my calculator out. We already have it typed into y equals. So I'm going to go to the home screen. On the calculator, I'm going to go start plus displacement. So I'm going to go 7 plus math what now? Math 9 from 0 to what? 4. Vars, where did I put the velocity equation? y1 dx, hit enter, there it is. So make sure nobody texts. All right, what do we get?
6.712.
711,558, which approximately is 6.712, whatever you decide to put. All right, now they want to know this. Okay, so that's 3 points. What is the fourth point here? It says, find the position of the particle at t equals 4. Is the particle moving towards the origin or away from the origin at t equals 4? So you're on a number line, and at 4 seconds, so here's 0 on the number line. At 4 seconds, you're at 6.712. There's at 4 seconds. There's your position right there. You're right there. You want to know if you're moving away from the origin. So the origin's over here. Am I moving away from it or am I moving towards? What would you need to know to figure out if you're moving away or towards?
Positive, negative.
What positive or negative? Velocity. Velocity tells you direction. If velocity is positive, you're moving which way? If velocity is positive, which way are you moving? To the right. If velocity is negative, you're moving what? All right, so you just need to figure out V of 4. Can you figure out V of 4? Yeah, you can just go to your home screen and do that. So all you have to do is go vars, y vars, function, y1 of 4. Oops, I don't know why I had a 0 there first. y1 of 4, or you could go to the table, whatever. Okay, you could go to the table and see what it is at 4.
Did you do a fraction? Yeah.
43.
Could you leave it in a fraction or do you need to find the decimal?
780 over 343, it's on the calculator. You're probably going to have the decimal. Okay.
What about the fraction?
If you got the fraction, just hit math decimal. It's math 2. Okay. Okay, so I got 1.213. Now, that's important. And it doesn't even really matter if you got the fraction. I don't even care what the number is. All I care about is that the number is what? It's positive. It's greater than 0 because it equaled 1.213064, which is greater than 0. And because velocity is positive and because we're starting on the right side of the origin, we have to be what? Now, here's the only way you get the point. I'm looking at the answer key. It says 1 point for movement relative to origin with justification. So that means you're going to say the particle moves away because x of 4 or s of 4, I used s, so let's just be consistent. S of 4 was positive. And what else? And V of 4 was what? Positive. Remember, if velocity and position have the same sign, you'll move away from the origin. If they're different signs, you'll move towards. Okay, we put that on the calculus essentials.
Can I just wait for the positive?
You can just put they're both positive. You don't have to use greater than 0. They don't care. You totally can write it however you want. Okay, part D. This one's worth 2 points. Let's see here. During the time interval from 0 to 4, does the particle return to its initial position? Give a reason for your answer. Okay, so if I'm going to say if it's going to return to its initial position from 0 to 4, what I'd have to do is, first of all, what's its original position? What was it starting? It was at 7. My question is it going to get back to 7? Somewhere in between 0 to 4, will it get back to 7? Okay, so here's what I would do. So during the time interval from 0 to 4, does the particle return to its initial position? Give a reason for your answer. We know x of 1. Did we not find x of 1 in one of these? What did we find? We found x of 4. What was x of 4 from the previous problem?
6.712.
6.712. That's from part C. Okay? All right, so here's the deal, okay? Look at the problem. We know that x of t, let's go back up to the original problem because this is using what theorem? What theorem is this using when we want to prove that it goes through a certain value? IVT, okay, intermediate value theorem. And I'm going to tell you right now, you're not going to, if you just put IVT down, you're probably going to get something. Okay, if you know it's IVT, it says it goes through all the values. So what we're going to do is we need to figure out, first of all, does the particle ever change direction? Okay, because we know that it goes from 0 to 4. We know it ends up at 6.712. Do you see that? Okay, so what I can do real quick, I can take my velocity equation, which I can't see it right here. I got to go back up here. You can take the velocity equation right here. Okay, go to y equals if you would, or sorry, go to your graph, not y equals. Turn your y, I do need to go to y equals because I got to turn the stupid y1 graph back on. Okay, go back and turn your y1 graph back on. Because you can use the calculator to basically answer this. What the heck, I don't want to do that. I just want to turn that one off. I'm just going to clear out y2 and y3. I don't need it anymore. I'm not going to turn them off. I'm just going to clear it out. So there's my y1. And I'm looking from 0 to 4. So I'm going to change my window from 0 to 4. So I'm going to change my window from 0 to 4. Graph it. And I know that it changes direction. Real quick, just look at it. Where does this thing change direction? It starts at 7. Does everybody see that it starts? We know. How do we know it starts at 7? Because they what? Told us. But this right here is velocity. This is not position. Everybody, this is velocity you're looking at. So area under the curve tells you what? So this is a positive velocity. So which direction are you moving right now? To the right. How much, somebody said it, area under the curve tells you how far you go to the what? Does that look like you're going very far to the right compared to this?
No.
Looks like I'm going further to the left. So I'm going to go a little bit to the right for 1 second. And then from 1 second to 3.5 seconds, what do?
Go left.
I got to see, do I pass back through 7? Okay, you started at 7. Do you agree? You started at 7? Mm-hmm. You went to the right, so I'm at 7 units. I go to the right for 1 second. Then what do? I go to the left till 3.5 seconds. So I'm probably going to, do you agree that I'm going to go back through 7? The reason I know this is because this function is what? Look at it. V of t is what?
Continue.
It's continuous from 0 to 4. Do you see any holes, jumps, or vertical asymptotes? So IVT applies, correct? So all I got to do is show what the position is at 1, and then I can use IVT. Okay, and I had to look at the graph to know that I changed direction. I started at 7, I was moving to the right, now I'm coming back to the left, so I'm probably going to go through 7. So here's your justification. So you had to look at the graph to get that. So what you're going to do, sorry, I went too far. You're going to show what x of 1 is. All right, start plus displacement. Start plus the displacement from 0 to 1 of v of t dt. Can we do that on our home screen? Yeah. Go 7 plus, math 9 or 9er. Go 0 to 1 of vars, y vars function y1 and tell me what it equals. And it's going to be approximately because it's a decimal again. Give me, I just need 3 decimals, so whatever. What you got?
9.404.
Yep. 9.404. Is that correct?
Yep.
So we know at 1 second it gets to 9.404. Is there a value that goes below it? From part C, we know at 4 seconds it's below 7. So I need to prove that it went through 7. Is there one above 7? Is there one below 7? So by IVT, it had to go through what? It had to reach its initial position again. So 9.404. Okay? Any questions there? And that's by IVT. So what you would say, your justification here is you'd say from t equals 1 to t equals 4, okay, the particle moves, or you could go ahead and say since, actually let's do it this way, I think it's easier. Since x of 1 is equal to, where am I at, 9.404, and x of 4 is equal to 6.712 by IVT, the particle must return to what? Return to 7, to a position of 7. You could say S of t equals 7 or x of t equals 7. And I didn't do this, but we talked about it. You would need to say that the function is continuous. And how do we know it's continuous? Because I looked at velocity, and if velocity is continuous, what has to be continuous? Position has to be continuous if your derivative is continuous, because that means that the original function was differentiable. So you would say also because v of t is continuous, s of t is continuous. And you only care about continuity from 0 to 4. So you might mention that from 0 to 4, because that's all we care about is continuity on 0 to 4, the closed interval. And that's a requirement of IVT. Okay, there you go. Number 1 is done. I think the calculators take the longest because we got to keep going back and forth. Okay, number 2, I'm not going to do, I'll do parts of this. I think there's one part that I haven't taught. I'm going to save that for, no, we can do this one. Never mind. I remember this one from last year. This one's kind of annoying. There's one part here that's really hard. Okay, there's going to be, you're going to get into a free response. You're going to probably feel really good about the multiple choice. You're going to feel like you got about 75. Most kids leave the multiple choice. I said, yeah, I feel like I got a lot of multiple choice right. Get the free response. There's going to be a free response. There's going to be 1 or 2 that are just going to absolutely wreck you. You're going to feel like, man, I just feel like I went through surgery. Yeah, it's going to be life altering. You're going to come out and you're going to be like, oh my gosh, that was crazy. Number 2, that's there. And there's always one that I get on the forums right after the exam. Everybody's like, students across the country saying, number 3, or whatever it is. So don't worry about it. So there's part in this problem that is going to be a little tough. Or put stuff down. Oh yeah. You get 15 minutes of problem. Yeah. And there's 1 or 2 that are pretty quick usually. There's a couple of them that you might go back to and be like, oh, I'm gonna have to come back to that. All right. During the time, here we go. During the time interval from 0 to 4.5. I'm ordering them this week. I wanna get sizes. I got the design set up. It's gonna be sweet. My daughter wants one too. I showed her this weekend, Maya, and she's like, Dad, I want one. You gotta order me one. I said, okay. So, all right, here we go. During the time interval from 0 to 4.5 hours, water flows into a tank. I would keep in mind that it said water flows into the tank because that's going to be positive displacement. Okay, at a rate means derivative, okay, of A of t. This is not acceleration. So go ahead and right now type that in your calculator because you need that.
That's not our calculator. Put that down, please.
Okay, so we got water, okay, from 0 to 4.5. Water flows into a tank at a rate of this, so that's going into my y equals. During the same time interval, water flows into tank B at a rate of B of t liters per hour. So they don't even give me an equation, but if you look up here, you can see B of t. You see A of t. They actually gave you the graph of both, so. And they're restricting their graph from 0 to 4.5, so you might want to go ahead and set your window from 0 to 4.5 if they give you a restriction. Both tanks are empty at t equals 0, so what's the start value for both tanks? 0. Okay? So big A of t, the original function, A of 0 is 0. Big B of t, B of 0 is 0. So that'd be the original functions. We'll call little a and little b the derivatives because they're rates. Rates means derivative. And it's in liters per hour, by the way. Keep track of units. If they give you units, there's going to be a point for units on the problem at least once. Actually, it's only once. They don't give more than 1 for units. Both tanks are empty at time t equals 0. The graphs of A of t and B of t are shown above, intersecting at t equals k and 2.416. So this right here is at t equals k. And I don't know what that is right now, but I know it intersects at k and 2 right here at roughly 2.416. How much water will be in tank A at 4.5? All right, so all I have to do If I want to figure out how much water, first of all, how much water's in the tank in the beginning? 0. So I don't have to do, I mean, there is a start value. It's 0. So if you do start plus displacement, you're going to have 0 plus how much displacement there is for A of t. So how do I set that up? And this is 2 points, by the way. How much water will be in tank A at 4.5? What do I do? The integral from 0 to 4.5 of little a of t dt. Right there's 1 point. Now type it in your calculator and you get the second point. Anytime you want to find the amount of something, you always do an integral. You're always doing displacement. Okay? All right, what do you got? Give me an answer. I'm not going to type this on the calculator, so you're going to do it for me. X, it doesn't matter. Your calculator doesn't care what the variables are. 66 point what? 5, 3, 2.
22.112.
Make sure your calculator's in radians.
22 point. I got the same. I got 60.
Make sure your calculator's in radians. It is 66.532. And it's, ready? Hold on, watch this. It's liters. Shh, don't worry, we'll have that fixed. Shh, liters per hour times hours. What's the units going to be? What's the units going to be? Liters. Liters of water.
Why had you get 10?
She put an X instead of Y1.
What?
That's why you're full.
Okay, yeah. Now, go to part B. Shh. During the time interval from 0 to K, now we're going to have to figure out what K is. Water flows into tank B at a constant rate. Now they're finally telling us what? Up to the point. Now look at B. Do you see how up to the point K? Does everybody see at point K? Look at B of T. What does it look like? It's a straight horizontal line. So they're telling us that B of T is really a piecewise function. It's a straight horizontal line up to K, and then after K it does what? It goes like that. So up to K, B of T is a horizontal line of 20.5. Okay? So during the time interval from 0 to K, water flows into tank B at a constant rate of 20.5 liters per hour. What is the difference between the amount of water in tank A and the amount of water in tank B at T equals K? Pretty straightforward here. First of all, I want to figure out what K is. Well, that's nice now because we have do we have the equation for A of T?
Yes.
And they told us this was a horizontal line up to this point. Agreed? So can I just figure out where that horizontal line equals that graph? So couldn't I go to Y2 and put what in? What could I do in Y2? No, you don't even need absolute values. You just put 20.5 into Y2 and then see where they cross. Yep, see where they cross on the graph. Don't need an X. And tell me what you get. So listen, by the way, you're trying to figure out A of K. 20.5. You're trying to figure out what that K value is. Where the horizontal line for B of T, that constant, that straight horizontal line for B of T, where it crosses A of T. You get 1 point for this. You get 1 point for finding this.
0.892.
Thank you. 0.892. I wouldn't round it yet because we're going to use this rounded answer. So if you're using a rounded answer to calculate something else, so let me tell you, when do you round? Only at the what? Very end. So do not round it yet. So you got to copy down every decimal value. 0.892040. Okay, you go to, did you type in your A of T into Y1?
0.5 in for Y2.
Yep, so you got to see where they cross from 0 to 4.5.
I was it not that, or why is it not the other one? No, I just didn't have the window.
You wanted to
big
cross it at 2 points. Good enough.
enough.
It only, but I won't, we already know that one. That was 2 point. They gave us that one in the directions, remember? And we're only looking at this first part from 0 to K. They told us where K was. If you look at your graph up here, K is right here. Does everybody see that? We don't need this one. Why do we not need that one? They already told us what it was in the directions. What they say, it crosses at T equals K and T equals 2.416. We want to know what K is. So It's 0.892040. Now, here's the next thing they want you to do. They want you to figure out when the difference, okay, what is the difference between the amount of water in tank A and the amount of water in tank what? B. Now, let's look at them. Which one has more water right now, B or A? Which one has a greater area under the curve? I'm going to erase all this. Okay, look at this. I'm looking just at this part, up to K. Okay, which one has a bigger area under the curve? A of T or B of T? B of T. So B of T's gaining more water quicker than A of T, and then eventually A of T is going to fill up quicker, but not till after K. So I'm going to do this as an integral. Are you ready? So far you've gotten 1 point for finding the point. Let's see, I can't, so I need my readers. 0.892040. You got 1 point for finding that. I need to zoom in on this. I can barely see it. Okay, now I'm going to do the integral from 0 to what? To K. Now, you don't have to copy that decimal down again. We labeled it K, so you can just put a K here. Save yourself time. Okay, which one was greater, the 20.5 or the A of T? Which one's greater? Somebody go open the door for Bjorn. Run.
Grab my shoe too. I was being a G to let people in, alright, cool.
Somebody run.
Hi, you've reached the voicemail of Bjorn Anderson. If you leave your name, number, and a detailed message at the tone, I'll be sure to get back to you as soon as possible. Bye, and have a great day.
That's so cute. All right. Not leaving a detailed message because he would never listen to it. All right, 20.5 minus A of T. Now, you technically need all this in parentheses with your dt in the back, or you will lose probably a point without that dt. So I want to do this right here. I want to calculate the integral from 0 to k of 20.5 minus a of t dt. I'm going to do that on my home screen. So we have everything on the home screen. So you're going to go to your calculator. You're going to go to the home screen. I don't have this typed in, so this is not going to, I'm not going to get the answer. But you're going to go like this. You're going to go math 9. You're going to go from 0. Now you got to put that decimal in. What was that decimal? Point what?
8922040.
Okay. Then we're going to go vars, y vars, function y1, dx, hit enter. It's going to work.
Get married.
I'm
then they're
teaching
legally-
Kay. What's up? You're on
Can
speaker.
you please talk to Bjorn? He's looking for you.
I'm in the, we're going to open the door.
Okay, call him.
Bye. Did somebody go open it for him? Okay. So what'd you guys get?
What up?
Are you at the door or not?
What door?
Front door. Door 1, where Elsa was going to let you in.
Yeah, I didn't know if it was at your house or the school, so. I'm like 3 minutes away.
All right. Somebody tell Elsa to come back.
Main Street.
Okay. We'll come open the door when you get here. Just text me.
All right.
Bye. So 10.5. Who got it? 10.59.
I got it right this time. Who got the 10? I got 7 too.
Who got 10.599? Because that's the answer.
Wait, but why did we not put the 20.5 minus?
Did you go 20.5 minus vars, y vars, function y1?
We all did it. I don't have to just me.
What'd y'all do?
We only
You
did
only
the
put
Y
y bars in.
We didn't do the 20.5 minus Y bars.
Oh, yeah, because I didn't.
Yeah, so I was probably told.
But I told you I didn't have them typed in, so that's fair. Okay, but anyways, I've got it written here. You got to type in the 20.5 minus because they wanted the difference between tank A and tank B. Now listen, let me explain this, and then you're going to go get it. Okay, let me explain this. Is this not calculating area under the curve of 20.5?
Yeah.
So it's calculating all that red area minus all that what? Blue area. So really it's finding the area between what? If you take the red area minus the blue, it's finding what? It's that finding, yeah, this little triangle, it's finding the area between the two curves, which is the difference. Okay? Because if you take all of the area under the curve, you get how much water is in tank B at that time. And then minus the blue area, okay, then we know the difference. We know how much more water was in tank B. So we know, so you could say the difference amounts of the water tanks is 10.599 liters. You don't have to know though. I mean, if you do, great. If you put, I know there's 10.599 liters more of water in tank B than there is of tank A. That's great if you explain that, but that's not what's required. They just want to know what's the difference in the tank. Okay, part B, done. Part C, the area bounded, listen up, the area bounded, the area of the region bounded by the graphs of A of T and B of T from K to 2.416. So now let's go back up and look at the graph. So now we're just talking about from K, from right here, K, which we know now is that 0.8, whatever, to this value, the area bounded by these two curves. So that's area between two curves. I taught you area between two curves on Friday, or actually Thursday. What is area between two curves? I told you. What do you do? Top minus bottom. Bam. That is it. It is top minus bottom. So here's all you have to set up. By the way, this is worth 2 points. So you go the area from K. You don't have to write K again because you already have K from part B. You already have it labeled. You never have to write K again. She's nice. 2.416. And then you're going to do, ready? Pay attention because we got to do the area under the curve. Wait a second here. I got to make sure. The area of the region bounded by the graphs of y equals A of T and B of T from K. Oh, I didn't even read the whole problem. Okay, let me finish reading the dumb problem. They already told us what the area between the two curves is. What is it? How much water is in tank B at 2.416? Okay, so this is an interesting question. Okay, because they're telling us that the area between the two curves. You have your calc stuff?
No. I left it all at home.
I'll give him some paper and pencil.
At least he's comfy.
Then I got in there, I walked in there and kid's like, did you get out of calc? And I was like, no, is there calc right now? And she's like,
This is why I don't leave a detailed message.
Wait, how'd you get this? It's open right now. There's still stuff.
yeah, somebody put stuff in there.
Okay, cool. Here we go. So, here's what we're going to do. If I want to find, let's just think about this a second. So, here's what they're asking. They're saying the area bounded by the graphs of A of T and B of T from K to 2.416 is this. So, I'm going to go back up there. This right here is 14 point what? No, what is it? 470. You were way off there, kid. 470. But their question is how much water is in the tank at 2.416? They just want to know how much is in tank B. The problem is we couldn't figure out how much was in tank B because I don't know this part of the equation. They didn't tell me that part of the equation. They did tell me the part of the equation from 0 to K. What was it? It was in the last problem. What was the equation for tank B from 0 to K? 20.5, right? So I can find that area under the curve, can I not? That's just that rectangle. It's the integral from 0 to K under 20.5. So here's what they want. And this is only 2 points, okay? I think. Yeah, this is 2 points. I want the area from 0 to 2.416 of little b of t dt. Here's what I know. I can find the area from 0 to K under b of t dt. Can I do that one? Because what is the equation for b of t from 0 to K? 20.5. We know from 0 to K, from 0 to K, not 4. I don't know why I put a 4 there. 0 to K, this equation is 20.5 dt. And by the way, there is a shortcut. I mean, you get to use a calculator for it, so you're going to type it in anyways. But from 0 to K, 20.5, can't you just do, and I know what my K value is because it was we found that it's, 0.8? So whatever. Couldn't I just take the width of that interval and just multiply it by this because this is a horizontal line and that's the property? If you have a horizontal line, isn't it just height times width? Yeah. But you're going to let your calculator do it anyways. Yes?
Would it not be 20.5 minus A
AFT dt, or is it just the 20.5 now?
It's just a 20.5 right now.
Why isn't it the minus? AAT?
Because all they're wanting to do, they said, all they're asking for is how much water is in tank B. So I just want to know how much is water in tank B. So what I need to do is I need to find, I'll erase all this, I need to find the area under the curve from 0 to 2.416 under tank B. Let's get rid of this too. Okay, that's all they want to know. Under tank B, this line only. Gosh, I just erased it. But this line only up to this point, I just want the area under the curve to there. Does that make sense? So we know that I can calculate this because we found K, and we know the equation is 20.5 right there. So we can do the integral from 0 to K under 20.5. What I've got to do, now here's what's interesting. What I've got to do is I've got to figure out from K to 2.416 how much area is under this curve without an equation. But they did tell us that the area between the two curves was that. So think about that a second. You have AFT, and I know the area between the two curves. This blue stuff is 14.7, is 14.470. So the area between two curves from K to 2.416, now make sure this makes sense, follow me here, is top minus bottom, just like she said. So I know it's A of T minus what? And we know this equals what? They told us. They told us in part whatever we're on. What part are we on? See? They told us this is 14.470. This was the one last year they were like, wow, this is pretty tough. Okay? Now look at this. You can split this integral, and you can do this because of a property. You can say the area from K to 2.416 of A of T dt minus the integral from K to 2.416 of B of T dt is still equal to 14.470. Do you agree that's a property and that's true?
Yeah.
Now, can we not find this? Don't we know what AFT is? Do we know what AFT is? Yeah. We do. So go to your home screen on your calculator and go the integral from K, which is the 0.89, what was it? 0.89, somebody tell me, 0.892040, is that it? To 2.416 of just y1 this time, of just vars, y vars function y1 dt, and tell me what that is. What do you get? What do you get for this right here?
44.497.
44 point, what is it? 497. Is everybody okay with that? Leave that on your calculator. Leave that on your home screen. Do you agree? And I've got minus the integral from K to 2.416. Now, the reason I can't find this here is because I don't have the B of T equation from K to 2.416. But I have a little algebra equation I can solve here. Can anybody tell me what you can do here to solve for the integral from... How can I solve this one? Take 14.470 minus what you have on your calculator right now. Go 14.470 minus what you have on your calculator, the 44.497, and then divide it by what? A negative. If you go 14, if you move this over, subtract this over, so 14.470 minus that decimal you had on your calculator, and then divide it by a negative, will you not have the integral from K to 2.417 of B of T dt? You will. What does it equal? Tell me what it is so I can write it down. So it'd be plus the integral from K to 2.416 of B of T dt, which you guys just found, is what? What is this? 30.027. You're not gonna erase that decimal. And then you're gonna add it to the integral from 0 to 0.89 or point whatever it is, 0.892040 under 20.5 dt. So you're going to add it to this integral here, and you'll get your answer. And tell me what that ends up being. There was a lot of explaining on this one. I believe it ends up being, what, 48.313? Yep, 48.313 liters of water. Sorry, Bjorn, you're just going to kind of have to wait till the next one. It's hard to enter the problem in the middle. That right there was tough. I think that's tough. I think some of you would really struggle. I remember last year they were like, man, that was really hard because you have to kind of think about, oh, okay, I got this part, and you kind of got to really understand what you're even being asked to do. Okay, the next one's not so bad though. Okay, part D. There's usually one really sticky part. Don't let that sticky part keep you from answering another part of the problem. Like part D is not bad. It says during the time interval from 2.7 to 4.5 hours, the rate at which water flows into tank B. Now they actually give you an equation for W of T. Wonderful. Plug it into Y equals. So I think or put it into Y2 because we might still need that. And I'd hate for you to have to retype it. So put that into Y2. Okay, and this is liters per hour. So this is how much water is flowing into tank B now. Is the difference between W of T and A of T increasing or decreasing at time T equals 3.5? That's not too bad at all. Now, here's what you have to be careful of. Okay, I'm going to read it. Before you do anything, I'm going to read it again. And you tell me what you think you need to do. I'm not going to tell you. You tell me. It says, during the time interval from 2.7 to 4.5, the rate at which water flows into tank B is modeled by this equation in liters per hour. Is the difference of W of T, little w, minus little a, increasing or decreasing? How do you figure out if something is increasing or decreasing? Of what? Of the derivative. I don't even care where I'm at right now. I want to know, are these rates increasing or decreasing? So what do I need to do?
Take the derivative?
You need to take the derivative of it. I want to know, are these rates increasing or decreasing? I want to know, is the difference between these two rates increasing or decreasing? So you need to be able to take, and at what value? So I need to know, is W prime, because anytime you want to figure out increasing or decreasing, you always drop down a derivative. You go down one derivative. I want to know, is the difference between little w of t and a of t? I didn't say the originals. I said, is the difference between little w of t and little a of t increasing or decreasing? So you got to drop this down one derivative at 3.5. So all you got to do is w prime of 3.5 minus a prime of 3.5. Do you have them typed into your calculator? Can you not just go math 8, y2 of 3.5? So you'll math 8 it because it's a derivative, right? And where did you put w? Where did you put w? Yeah, we're going to put 3.5 in, but where did you put your equation for w? Y1 or y2? So you're going to math 8 y2 of 3.5. Math 8 y2 of 3.5. Minus math 8. Where did you put a of t? Y1 of 3.5. And I would do it all in one step. So it'll look like this. I don't have the equations typed in, but this is what it looked like. I'd just go math 8, and I'd go vars, y2, and then put 3.5 in. And then I'd just go minus. I'd go math 8, vars, y function y1 of 3.5. Now, I don't have the equations in, so I don't know what it is because I didn't type them in. But what did you guys get? Negative 1.14298, whatever. And is that greater than 0 or less than 0? Sign analysis is what somebody said. We just did a sign analysis. We figured out it's negative. And because it's negative, therefore it is what? So we'd say the difference between, you don't have to say between, the difference between W of t minus A of t is decreasing at t equals 3.5. Did you subtract it the right way? Did you go ddx of y2 at 3.5 minus ddx of y1 at 3.5? And then you might have typed the equation in wrong for what? W of t. Did you go 21 minus alpha x? There it is. That's all the spot. Hey, all right, good. We are done with problem 2. We are done with the calculator part of the for response. Now, the non-calculator ones do not take as long. Okay, they don't take as long. They're not as hard. Most kids, there might be one that's still hard because you might not just know what to do, but they're a little bit easier to handle as far as like the understanding of it. And the reason they go a little bit more in depth on the calculator part is because you have the calculator to kind of explore things. Okay? Is there somebody else here?
No, I have to go back.
Do we need a break real quick? Or are you good? Can I get one more problem done, then take a break? Okay, here we go. The function f. The function f is consisting of 3 line segments and a quarter of a circle as shown above. All right, I can guarantee a particle motion problem on the exam. I can guarantee a problem like the last one where you're figuring out increasing, decreasing. They might ask for area under the curve, displacement, where you're trying to figure out the amount of something. You can guarantee that's going to be on there. You can 100% bet your, bet all the money in the world that you have on the fact that this is going to be on there. Okay? Which some of you don't have a lot. Okay? But if you had a lot of money, you could take it to the bank. You could bet with that amount of money, and I guarantee you're going to win because they have this every year. It's an FTC problem. They're wanting to test your ability to do FTC Part 1 and FTC Part 2. All right, so let me just review FTC Part 1 and Part 2 before I even do anything. FTC Part 1 was the derivative of the accumulation function, d dx, ready, of the integral from a to u, but remember u is in terms of x, of little f of t dt. Now, who remembers, what is the rule when you take the derivative of an integral from a to u? Just plug u in. So it'll be f of u times what? U prime. Now, most of the time, what's up here? Most of the time, what's up there? It's just an x, so you just plug in x, and that's your derivative. Okay? But sometimes it's not an x. We're going to see in a minute. I think it's probably going to be an x. And then that's part 1. That's FTC part 1. You can't, I'm telling you right now, people, you got to be able to do that. Okay, it's going to come up. Okay, FTC part 2 is probably the one you like best. It's what everybody likes best. And that's just calculating an integral from a to b. It's just how you calculate displacement. Okay, and all you do is you get the antiderivative, which is big F, and then you evaluate from a to b, and then you do top f of b minus what? F of a. So there's FTC part 2. So that's FTC part 1, part 2. Now, I don't think you're going to use part 2 here because you don't have an equation. So you're actually going to find the area under the curve using geometry because they gave you 3 line segments and a quarter circle. So this stuff here, when we calculate displacement, we're actually going to use geometry to do. Okay? You'll probably do a ton of this on the multiple choice, though. All right, the graph of function f consisting of 3 line segments and a quarter of a circle is shown above. Let g, oh, yep, it's from 1 to x. That's nice. So when I take the derivative of it, you can go ahead right now and tell me what g prime of x is. What would g prime of x be? I just wrote down FTC part 1. What is g prime of x? Thank you, f of x. Well, times the derivative of x, which is just 1. Okay, so it's just f of x. The derivative of g of x, look, FTC part 1. When you take the derivative of the accumulation function, you just plug x in. So it's just f of x. What would g double prime be? I guarantee you we're going to use it. F prime of x. That's going to be your derivative. That's going to be your second derivative. You can only do it symbolically. Which means when I do the second derivative of g, I'm going to look at the what of f. When I do the second derivative of g, what am I going to look at on f? The slopes. Very good. All right, find All right, you're gonna love part A. Here we go. I gotta look at the points here. I love seeing the points. I can't believe this. I can't believe they're doing this. They're giving you 3 points for this crap. Yeah, I can't believe they're doing this. Find A rock from what? Now, Bjorn got a little confused on this when we were doing multiple choice, and then he finally figured it out. They will probably write it like this. Okay? But I know that means, all right, okay, not a big deal. Figure out G of -5, and then figure out, oh, I know why it's 3 points now. Because you're going to have to figure these out. Okay? How do I figure them out? I plug into function G. So the first one's going to be the integral from 1 to -5 under little f of t dt. So we're going to have to find the area under the curve from 1 to -5. So go ahead and right now tell me what do I have to do to that integral first. Flip the limits of integration and put what out front? A negative. Because you need the smaller number at the bottom. Or you need to remember if you go to the left that the area is going to have to flip. So either way. Okay? I like just dealing with it right away. So I just want the area from -5 to 1. All right, here we go. Here's 1, 2, 3, 4, 5. So from -5, we got a triangle here. Let's do this one first. 1/2 base. Looks like the base is what, everybody? 3 times the height. What's the height? 4. So it's 3 times 4. So that'd be 12. Half of 12 is what? I'm going to label that. And label neatly when you're on the exam, because you will have paper and pencil for the free response. It's not on the computer. Because don't be messy, because if you're messy, you're going to use this one graph as all you get. You don't want to have to redraw it. And you don't want to have to erase it.
Problem gonna be on paper?
Yeah. It's all on paper for the free response. The only thing that's on the only computer is the multiple choice. And you get paper to do the problems.
Oh, that's nice.
Okay. All right, next, quarter circle. All right, we want all the way to 1. We want all the way to 1. So we got to get this little triangle. I'm going to get this little triangle real quick. That's 1/2. Base of 1, height of what? 2. So that's going to be 1. Agreed? All right, this is a quarter circle. Don't screw this up, because if you remember, in 2015, you were here for it. I did a semicircle instead of a quarter circle, or vice versa. I can't remember which one it was. So it's pi r squared divided by what? 4. The radius is 2. So it'll be pi times 2 squared over 4. So it's 4 pi over 4, which is just pi. All right. So I'm going to take all that and add it up. But it's all negative area, is it not? Is the area all negative? Correct? All right. So it's going to be -7 minus pi. So it's going to be the opposite of -7 minus pi. Why does it end up being the opposite? Because you were going to the left. And so it flips the area. So it makes all that negative area. It makes it what? So it's actually 7 plus pi. So there is, that was a little bit of work just to get your first point. Now you see why it's worth 3. Then I got to get G of 5. So that's going to be the area. That'll be a little bit easier. That's just the area from 1 to 5 under little f of t dt. Okay? So the area from 1 to 5. All right, I can do that. From 1 to 5, let's see. Right here's 1 to 5. Oh my gosh, I can do that triangle. You could do a trap if you want, but I'm going to do a triangle and a rectangle. That's a 2 by what? 4. And this is a 2 by 4, which is half of that. Yeah, duh. It's half the rectangle. 4. What's 4 plus 8? 12. There you go. Now we can find A rock. And that'll be the last point. So you got 1 point for each one of those, and then you get 1 point for doing A rock. So it's going to be 12 minus 7 plus pi over, how are you doing it? Which one am I subtracting? 5 minus a -5, and they don't care if you go ahead and put 10, actually. So then I'm going to end up with 5 minus pi over 10. There's your answer. 3 points for that. How many think you could do that? A rock. You got 2 weeks to figure this out. If you had 1 week, I'd be worried, but we got 2. And I'm going to be here that whole last week before the exam.
What time is tomorrow?
7. It's the only day I'm coming in this week. You just sleep in the rest of the week.
Tomorrow?
Yep. This is my last day here. I'm gone Tuesday to Friday. I'm in Georgia. So, what?
When are we doing the quiz?
Tuesday. Yeah, because I didn't want to waste. You don't want to miss the FaceTime. Okay. All right. Here we go. I am going to FaceTime in class one day from Georgia. Find the instantaneous rate of change of G with respect to X at X equals 3. State whether... All right, this is easy. Instantaneous rate of change of G. What does instantaneous rate of change mean? What does IROC mean? Derivative. So I want the derivative of G. So I want G prime of 3. Well, guess what? We already did G prime up here. What was G prime? F of X. Remember, the derivative of the accumulation function is just plug in X. So G prime was F of X. So I'm going to write that down. G prime of X is F of X. So if I want to calculate G prime of 3, all I need to do is actually figure out what F of 3 is. All I got to do is look at that point on the graph. This is only worth 1 point. Sorry. All right. Can somebody go up and tell me what F of 3 is? It is 4. All right, there you go. G prime of 3 is 4. Okay? And it does exist because there's a point there.
So if you put F of 3 equals 4, would that be wrong?
I'd put G prime. Actually, they have it both ways, but as long as you label G prime as F of X, then it would be sufficient. So he's asking, could you put G prime of 3 or could you put F of 3? You could put F of 3 as long as you labeled up here G prime of 3 as F of X. Then it would be totally fine. All right, next part C. Ooh, concavity. I like this. I think these are easy now. On what open intervals? All right, now we're actually going to need to do sign analysis because we got to find the intervals of where the graph of G is concave up. If I want to figure out where G is concave up, let me ask you. Let's just go through this. When do you figure out if G is increasing or decreasing? G prime. When do you figure out if G is concave up, concave down? G double prime. We already know G prime of X is F of X. So what is G double prime of X? So we need to look at the slopes of F to figure out G double prime. Where the slopes are positive is where G double prime is going to be positive. Where the slopes are negative is where G double prime is going to be negative. Now I just want to look for where it's concave up. So what kind of slopes am I looking for? So I just need to go up there and look for positive slopes and answer it and justify it. So all I got to do is go up here and say, okay, it's going to have positive slopes. I'm gonna highlight it. Here we go. It's positive slopes there, and it's positive slopes there. All right, give me the intervals. You tell me. Guys, you ready? Give me the intervals. What is it? -5 to -2, and what else? 0 to 3. And you got to say because. And I would say start with saying G is concave up. G is concave up from -5 to -2 and 0 to 3. Because, now why? Because why? Because G double prime, because you can either say it this way. You can say G prime of X, which is F of X, is increasing. That's one way you can do it. That's one explanation because we were looking for it to have positive slopes. Or you can say increasing or positive slopes. I don't care. What's another way you can say it? G double prime, which is F prime, is positive. Why is it positive? Because F prime has what kind of slopes? Positive slopes. It doesn't matter, but you got to include somehow that you're looking where F prime has positive slopes. You got to look. The reason I knew G double prime is positive is because F prime had positive slopes. That's the connection you got to make. If you make that connection, you are going to get 2 points for that. 1 point for the answer, 1 point for the justification. Last part D, and then we'll take a quick break. For what values from -5 to 5, okay, find all values from -5 to 5 at which G has a critical point. Let's start with that. Okay, so G has a critical point where G prime equals 0 or what? We're looking for the critical values for G. So we got to go to the first derivative. So what am I looking for? We're looking for g prime of x, which is f of x, when that is equal to what? 0 or? Now, is it ever undefined? Is f of x ever undefined? Look at f of x. Is it ever undefined? No. Now, don't say, oh, no, it is undefined. It's undefined here and here. That's g double prime. Corners and cusps. Okay? So, that's not this, though.
Isn't it once defined, always defined?
No. Once undefined, always undefined. Okay? I can be defined in a minute. If I took the derivative of this, which would be the second derivative of g, because of a cusp there, that is going to be undefined if I take one more derivative down.
So then anything beyond this.
That would be undefined, yes.
Yeah.
Once undefined, always undefined. Now, so here's what I do. Are there any critical values from -5 to 5? We know this is out. So is there any place where g prime, which is f of x, look at f of x. Is there any place where it equals 0? Tell me what it is. I can't look at the graph at the same time, so. -2 and what? That's 1 point right there. Just knowing you had to look at where f of x was equal to 0. All right, so g prime fx equal to 0 at -2 and 1. So these are the critical values. Now, so I can, oh, by the way, you got 1 point for just setting that equal to 0. Just knowing to set the derivative equal to 0. You get 1 more point for the answers. So you got 2 points.
So if we don't like rewrite some of this stuff, we're gonna miss points.
Well, how are you finding when it equals -2 and 1? You got to tell them.
It can't be like previous work done.
No, not on this part. You got to show. Yes, question.
Hypothetically, if we got 0 points in the free response, would we just fail?
Yeah,
Really?
you have to get a certain percentage of the free response to get it right. Yep.
Well. So I really have to pay for the test?
Yep. Sorry. Already been ordered.
Don't take coupons.
No coupons. No massage my back coupons.
No, buy one, get one.
No. All right. So here's the deal. Shh. So you just know, take the derivative, set it equal to 0, and then know that, okay, all I had to do. Now, it doesn't matter. It doesn't matter. When they said critical values, you automatically should have known, oh, just take the first derivative, set equal to 0. That's always what critical points are. And they don't care if you go g prime equals 0 or f equals 0, because you've already stated somewhere on your paper that g prime is f of x. So they don't care. They will let that slide. If you state that g prime is f of x, they see you already have made that connection. So if you just know to say g prime equals 0 or f equals 0, it doesn't matter to them. Then you get 1 point for the answers, and now you get 1 point for classifying it as a max or min. I think specifically it asks what is -2 and what is 1. So if I want to classify these, since f is the derivative of g, I want to know, let's look at -2. Go to -2. -2, is this a max or a min? Well, the derivative goes, it's negative and it stays what? It's below. Do you agree? So is -2 anything? -2 is neither a max nor a min because it goes from decreasing to what? Decreasing because it was below the x-axis. We're not looking at slopes right now. That would be the second derivative, which would be concavity. Now look at 1. 1 goes from below to what? So what is that one? Relative min, because the derivative of g goes from negative to positive. So -2 is out because the derivative of g went from negative to negative. And then 1 is a relative min because g prime went from negative to positive. Okay? And they like using g prime. And you can just simply say g does not have a local min at -2 nor a local max. You can just say there's no relative extreme at -2 because g prime does not change signs. You could say g has a local min at 1 because g prime changes from negative to positive. Just like we did on that 294-point assignment. Okay? All right, go to number 4. Here we go. Oh, let's stop real quick.